This video is over systems of equations and specifically solving by substitution. Just to review some of the vocabulary that you reviewed in your last video and then our new one down here about substitution. A system of equation is two linear equations graphed simultaneously, which just means at the same time. A solution is the point of intersection of the two equations in the system. The solution satisfies both equations, making them both true. And then the one that you're going to add to your notes is this one right here about substitution. To solve a system by substitution means you replace one element of a mathematical equation or expression with another. And in this case, we're focusing on equations, not expressions, since it's a system of equations, but you could do the same thing with an expression. Similar, if I knew x was equal to 4, I could substitute x in for, or I could substitute 4 in for x in this expression. But again, we're looking at equations. So I've got 3 examples for us to try, and these examples are, they're not too difficult, but notice kind of the differences and similarities between the few. Okay, so here's our first example, and this is a great idea to use substitution on this example. We notice that both of our equations are y equals some quantity. For instance, this one says y equals 2x, and this equation in the system is y equals x plus 5. Since both of these equations equal y, that means they also equal each other. That's kind of like the transitive property. If y is equal to 2x and y is equal to x plus 5, then 2x must also be equal to x plus 5. And notice when we write this equation, we only have one variable now. So we're actually able to solve for x, and then in turn that will help us solve for y. So to do that, let's just subtract an x on both sides. So now I have 1x equals 5, or just x is equal to 5. So these two, this system of equations, the intersection point, the x value is 5. From there, we're going to take that x equals 5, and we're going to substitute that x equals 5 into either equation to figure out what y is. It does not matter which one you choose, just completely preference. So if we know x is equal to 5, I'm going to use the top equation, and y is equal to 2x. I'm going to substitute that 5 in for x, so I have 2 times 5. Y must be equal to 10. So I know my solution to this system is 510. Just to make sure that's correct, I can check it with the second equation. If I check with x plus 5, y is 10, x is 5, 10 equals 5 plus 5. That's a true state. So I know that's my solution. So again, when you have two equations equaling the same variable, like how these two equations equal y, using substitution is a good idea. Let's go ahead and look at our second example. In this case, we don't see the two equations equaling a variable. For instance, this one equals 6 and this one equals 3. But substitution is still a good strategy to use on the system because one of the equations can very easily be solved for a variable. They actually both can. The one I was initially referencing is this bottom one. I could easily rearrange this to get y by itself. For instance, I could subtract x on both sides, and I'd be left with y equals negative x plus 3. Now, when I look at this, since this quantity is equal to y, that means I can substitute this quantity into our equation up here for y. Again, since y is equal to this quantity, negative x plus 3, that means I can substitute that into the first equation. So let's try that. We've got, from our first equation, x plus 4, except this time, instead of writing y, I'm going to write what I know y is equal to, which is negative x plus 3. Again, that came from right here. Now it's just we only have one variable, it's the x, not 2. From here, I'm just going to use distributive property. So I would have 4 times negative x, which is actually a negative 4, so I'll write that, negative 4x. And then 4 times 3, which is positive 12, equals 6. Combining like terms, 1 minus 4 is negative 3x, plus 12 equals 6. Subtract 12 on both sides, we have negative 3x equals negative 6. Divide by 3 on both sides, and we get a positive 2. So right now, I know that my solution to this system has an x value of 2. Just like the problem we previously did, I'm going to take that x equals 2, and I'm going to substitute it back into either equation to figure out what y is. Again, it doesn't matter which one you use. I'm going to choose the second one because it's a heck of a lot easier. So from there, we've got x plus y, if we know x is equal to 2. X plus y equals 3. 2 plus y equals 3, and obviously y must be 1. So the solution to that equation, that system of equations, is 2, 1. I can mentally check that really quick, 2, 1. 2 plus 4 times 1 is 6. I know I have the right answer. All right, and then our last one that we're going to look at is this equation right here. So again, I look in this case, and one variable, x, is on a side by itself. So that's going to be really easy to substitute this quantity in for x into our equation below. I don't need to rearrange anything because I have a variable by itself. But if we did, just like in example 2, we would just rearrange it so we would have a variable by itself to do this substitution. So since I know that the quantity of x is also equal to 2y minus 4, that means when I write this equation out again, instead of x, I'm going to write 2y minus 4 plus 8y equals 16. Again, I substitute the quantity 2y minus 4 in for x, since I know they're equal to each other. From there, and I combine like terms, that would be 10y minus 4 equals 16. I add 4, that would be 10y equals 20, and I divide by 10, I get y equals 2. So my first part of my solution is 2 for my y coordinate. Now I'm trying to figure out my x coordinate. We're going to take this and substitute it into either equation. It doesn't matter. I'll do the top equation. So we've got if y equals 2, I've got x equals 2 times 2 minus 4. 2 times 2 is 4 minus 4. X must be equal to 0. So that is our solution to this system. So just to wrap up, anytime you're solving using substitution, some things to look for to see if substitution is the best way. In this example, if you have a variable that is by itself already, that is a good idea to, I'm not sure why it's not highlighting, come on. Well, nope, okay. Whenever you have a variable that is equal to another quantity, that's a great way to use substitution. So that was like how example 3 and example 1 were. With example 2, I chose to use substitution because I could easily rearrange the equation to get a variable by itself, like y. I also could have subtracted y on example 2, and it would have been the same thing. So try the practice problems below on graphing and substitution, and move from there.